This is section 1.7, number 18. I'm starting off with a picture that's a little different than the one given in the book, but this is an autonomous slope field. We know that because along every horizontal line, well, I'll try to draw a line. Along every horizontal line, we are seeing slopes that are uniform. So here, poorly drawn, but you get the point that along every horizontal line the slopes are the same. I can illustrate it more with this highlighted. Look at this horizontal line, which I believe is an axis, and we see the slopes are the same value. Okay, and the effect of this is that solution curves for autonomous equations have shapes that are simply horizontal translations of one another's. And you can see it very clearly here. This blue curve is a solution curve that's going through this initial value, for example, or this initial value. One of the points along the curve is known, and then the curve is drawn. Here is another solution curve, and notice that this is simply a horizontal translation. This point is translated to here, this point is translated to here, this point is translated to here, and that translation is the same distance every time. As I go from here over, that distance, d, let's say, will be the same distance as I go from here over. Okay, from here over. There's a horizontal translation happening among the solution curves of autonomous differential equations. Okay, that's the key fact. Okay, so I'm going to go to the next page, and I'm going to make a rough sketch of what we're given in this problem. In part A, we see what looks like an exponential function. We see something that comes down like this. And we're told that this point is at the height of 3, y of 0 equals 3. And we are asked the question, how much of the slope field can you sketch from this information? Well, I'm going to change colors here and make the point that along every horizontal line, so actually I should only be drawing horizontal lines that go to the edge of the known curve. I'm not doing a great job with that. But we know that along every horizontal line, the slopes are consistent. So for example, here I see a slope, some negative slope, looks like, let's call it -1. So that means all along this horizontal line, I'm going to see slopes that are -1. So I can draw, and let's take this one here, the slopes are a little flatter. So that means they're going to be flatter all along this horizontal line with the same magnitude. So whatever region is contained by this known solution curve, I can draw a slope field inside of this box simply following. So once again, right here, I see the slope is still a negative value, and as I move along this horizontal line, I would draw the same slope field. Okay, so part A, how much of the slope field can you sketch from this information? I can sketch everything inside of this red box, basically. That's that answer. In part B, they say, well, I'm going to redraw the original picture roughly. In part B, you're given this picture. Again, this is the value 3. This height is 3. We pass the point 0, 3. They say, what can you say about the solution curve with y of 0 equal to 2? So let this be 2, for example. Okay. And what I do is so I know that my solution curve passes through this point. But because it's autonomous, and on the previous slide I showed you that autonomous solutions are simply horizontal translates of each other, then I'll dot over to here. Try that again. I will take a dashed horizontal line to here, and the value of the slope going through 2 is the same as this slope, because along every horizontal line it's the same. I'll call this translation distance d, and that means that each point here along the known curve is translated a distance, some distance d, and then this will be my point on my solution curve. I take this one and I move it over d. This will be a known point. And essentially I'm drawing a curve that is a horizontal translate of the black curve. So the blue curve going through 0, 2 is a horizontal translate of the black curve, where we're moving over in each case, I'm sorry, it's so crooked, by an amount d. And so that's what I can say about the solution that goes through 0, 2, knowing the solution that went through 0, 3. That's it. Thank you.